Hello, it's Neha again and welcome back. We are on problem 3 in our NeetCode 150 journey. Today's problem is a classic one. You will see it everywhere in interviews, online assessments, and even real-world projects. It's called two-sum. It's the kind of problem that looks simple but teaches you a lot about efficiency. So let's break it down. The problem statement here is as follows. Given an array of integers nums and an integer target, return the indices I and j such that nums I plus nums j equals target and I not equals j. You may assume that every input has exactly one pair of indices I and j that satisfies the condition. That means there will always be one valid answer, and we are supposed to return the indices with the smaller one first. The example one is as follows. It has 4 elements 3, 4, 5, 6 and the target number is 7. Here, if we add nums 0 and nums 1, that is 3 plus 4 equals 7, so the output should be 0, 1, which is exactly the indices value of 3 and 4. Okay, so let's think about the simplest way to solve this problem, the brute force way. What we can do here is, we loop through every pair of numbers and check if they add up to the target. That means, first loop picks I, second loop checks all j greater I. And if we ever find a pair such that the sum of the pair is equal target, we return the indices I and j. Here's what that looks like. For I in range, length nums. For j in range, I plus 1, comma, len nums. If nums I plus nums j equals target, return I comma j. This is very simple approach and this will definitely work. Let me run here and show you that all test cases will pass. Okay, we are missing a semi, we are missing a colon here. Let's rerun it. As you can see, this is working, but the time complexity becomes big O n square as we have used 2 for loops. And if the array gets bigger, this becomes slow. Can we do better here? Yes, and this is where hash map comes in picture. Let's say we loop through the array once, and for every number we calculate the complement, the number that would add up to the target. So what we are trying to achieve here is complement equals target minus nums I. Then we will ask, have we seen this complement before? If yes, we already stored it in the hash map. That means we found a valid pair. And if not, we add the current number and its index to the map and move on to the next element. Let's comment this out and try the hash map way. We will first create an empty dictionary to store each number and its index. Let's name it nums map. You can definitely name it as per your preference. And then we will initiate a loop for I in range len nums. We have initiated a loop to go through the entire array once. And then what we are going to do here is we will subtract the nums I from the target and store it in complement variable. So complement equals target minus nums I. And then what we are going to do here is we will check if the complement is already present in the hash map. If complement in nums map, if it's there, we will simply return the indices value. And finally, if we haven't found the number in hash map, we will simply add the current number and its index to the map. Nums map nums I equals I. And here our code is ready to run. Let's run this and check everything works out. As you can see, all the test cases are passed and the code is working perfectly fine. This approach gives us time complexity big O(n) because we are only using one for loop. And this one for loop is running through the entire array once. Also, the space complexity here is big O of n. We store each number in a dictionary, which at worst takes up to n space. And compared to the brute force method, this is much faster and scalable. Alright, let's quickly go through the constraints here. The array given will always have at least 2 numbers and at most 1000, so nothing too huge. Also, the value inside the array as well as the target number can be anywhere between negative 10 million and positive 10 million. And here is the key part. The problem guarantees that there will always be one valid answer. So we don't need to worry about checking if a solution exists. It definitely does. And that's exactly why the hash map approach works so well here. It's fast and efficient, and it easily handles the size and the range input we are given. And that's our problem 3 solved. With a clean, efficient Python solution. We started with brute force here, as you can see. We started with brute force, saw why it's slow, and moved to a one-pass hash map approach that works in bigger one time. If you're solving this with me, stay tuned and we will go through all 150 problems one step at a time. Next up will be group anagrams. For now, bye-bye.